Alright, so it's the last lab. Woo! So Unit 6 lab, use the procedure page to make sure you get the right number of drops of each chemical in. I know this is the most tedious part of the lab. I know it takes a little while. If you make mistakes, it's no big deal. Just redo it in a cell that's in a well that's on the outside of the row. Alright, because I know I actually, doing it, I had at least one mistake in each one. So I just, on one of my extra plates, put it in the exact same spot in one of those outside wells so that I could tell where it was. Okay, hopefully you won't have issues counting like I did, and you won't have to do that. The other thing I want you to do is make sure that you stir all of your samples. Alright, because I noticed that upon stirring, it actually did change what things looked like. Okay, so this is my data from the first set. And if you notice in row A, well number 5, after stirring, it actually showed me things that it actually looked like there was less precipitate in there. All right. What it did was it just spread it out more so that it wasn't, all clumped in on the top layer or something like that. And then I also noticed that in B, it kind of, much slighter change there, but it almost looks like maybe it looked like more complete precipitate. Alright, so make sure you stir just so that you're not being led astray by what things look like before stirring. Okay. Okay, so now the most difficult part to this lab, and I really don't feel like the question actually explains itself well enough for you guys, is the second question on the lab report, where it says, below are the balanced equations for the reactions in parts 1 through 3. Review the results of your experiments and look closely over the mole ratios of the chemical reactions. Do your experiments reflect the stoichiometric molar amounts indicated by the reactions? Discuss this using evidence from your experiments. Okay, so this is where you want to look at the wells that made the most amount of product. So according to our reaction, okay, the balanced reaction, we don't write the ones in, but I'm going to add it for right now. The reaction says there should be a 1:2 ratio of copper nitrate, the CnO3 2, to NaOH. Which means to get the most product, we should have twice the amount of NaOH to the amount of copper nitrate. All right, so that's what we expect. Now we need to sit there and look at it and see what we actually got in our data. So that's where you want to look at your two wells that have the most, which were 6A and 6B. All right. So I'm going to move this up so that I have some room. So looking at 6A and 6B, in 6A, I had 20 drops of CuNO3 to 30 drops of NaOH. Right? I want to simplify that ratio so that I can compare it to 1:2. While this is in math class a bad thing, in science class it actually helps to get this stuff down to decimals. So if I do 30 divided by 20 and 20 divided by 20, I'm going to get my simplified ratio. 30 divided by 20 gives you 1.5, 20 divided by 20 gives you 1. So this is a 1 to 1.5 ratio. So not quite 1:2, but close. Now if I do the same thing with 6B, I have this time 15 drops of CuNO3 or copper nitrate to 35 drops of the NaOH, or sodium hydroxide. So I'm going to give myself a little bit more room. So what that's going to do is if I simplify that down, I divide both numbers by the smaller one. So 15 divided by 15 is going to give me 1. And 35 divided by 15 gives me 2.33. So if you look at these two ratios, neither one's exactly 1:2, but one's a little bit less than it, one's a little bit greater than it. And those gave me the highest amount of precipitate, the most product. So what that means is, you know, if I did one that was perfectly a 1-to-2 ratio, that one would probably make the most. But because the two that have the most are the ones closest to 1-to-2, that makes sense. That actually does match the reaction. So what I would say to answer the question is this. And you can use this, you can put this in your own words, but don't copy it word for word from my video. So let me move this up so I have some room to type. Come on, sorry. And typing. So what I would say is, based on the balanced reaction, I should make the most product when my ratio for copper nitrate to sodium hydroxide is 1-to-2. In the lab, the wells with the most product were A6 and B6, or 6A and 6B. Sorry, I flipped my numbering there. 6A and 6B, respectively, which I spelled wrong. There we go. These wells had ratios of 1 to 1.5. So when I say respectively, that means that the first set of numbers I give is for 6A, the second set of numbers I give is for 6B. So 1 to 1.5 and 1 to 2.33. Since these ratios are the closest to 1-to-2, my evidence does correlate or match what is expected by the equation. And then you would do that again for each part of the lab. All right, so I did the first one for you, you got to do the other two. So if this doesn't make sense, please come and get help. But for the most part, you should find that the ones that make the most are going to have the closest ratios to what you actually see in the balanced equation. Now, the key to getting full points on this part is this evidence from the lab, where you actually show me the ratios of your lab data. All right? That's where you're going to get the points for your evidence from your experiments. If you leave that part out, you are going to lose points, okay? So again, if this doesn't make sense, come get help.